One of the most important concepts in mathematics is the concept of a function. So much of what we do revolves around the way variables are connected to each other. At the moment, we're only working with two variables, usually x and y, or something that's behaving in the place of x and something behaving in the place of y. We can have three variables, x, y, and z, and then we can move on to multivariables where we have lots and lots and lots of different variables in the one function that all are related to each other somehow. Before we get on to the idea of function, though, we need to have a look at this concept of a relation. And a relation, as the definition in your booklet there states, is simply a set of points which connect two variables in some manner or another. There's less rules about relations, and there's a few examples here for you on the page. It's usually expressed with an equation, but not always. So some of the relations that we're familiar with, a straight line is a relation, okay, and we know that in this particular example, y is connected to x, in that y is 3 lots of x plus 6. We can work out any y value using that rule. Another example of a relation is a circle, and we've got a basic function of a circle, a basic relation of a circle, I beg your pardon here, which is x squared plus y squared minus the radius squared. So in this case, the radius is 9. 9 squared is 81. We'll be looking at circles quite a bit more extensively later in this chapter. An inequality is also a relation. So here, instead of y equals 0.5x minus 5, we've got y is greater than 0.5x minus 5. So here's the line, which would be y equals 0.5x minus 5. It's a dotted line because we're only interested in the bits that are greater than that line, not equal to it. And you can see that the region above it is shaded. Now, on your photocopied booklets, for whatever reason, the shaded region hasn't come out very clearly. So can you please shade that in to indicate that that's actually the relation, all of those points above that line. You might like to have a think about this, but can you recognize that there are, in fact, an infinite number of points above that line? Depending on exactly what coordinates we use, there is literally an infinite number above. There's also an infinite number below that line as well. A fourth type is one where there's no equation at all. So here you can just see that we've got these dots. There's really no rule connecting these dots, but they are a relation because they're x and y coordinates connected somehow. The next little bit is this concept of a mapping diagram. I don't think we've met these before, and we're going to do a little bit more work with them as we go on. So a mapping diagram is just another way to describe a relation, and it shows us the connection between x coordinates and y coordinates. So having a look at this mapping diagram here, we've got the x coordinate of 3 connected with the y coordinate of 1. So that tells us that -3, 1 is a point in this relation. Then we've got 0 connected with 6. So that tells us that 0, 6 is also a coordinate. We've got 2, 9. And we've got 6. Whoops, I'll just put a circle around it. We've got 6, 1. So all this tells us is that these coordinates are connected somehow. Sometimes the rule is obvious, sometimes it's not. Sometimes there is no rule, they're just a set of connected coordinate pairs. So that's the idea of a relation. A function is a subset of the relation, and we'll talk about what makes a function special in the next video.